Aloha, Rich Alverson here. This is ICS129, ITS129, and this is the first day of the semester. And so today I'm just going to talk a little bit about the course and what you need to do well in it. So I'm going to share my screen. I'm going to share number one. Wow, that's interesting. Okay. All right. So log into Lamaku. That's lamaku.hawaii.edu, and then log in. What is this? I'm not sure who can share. Okay, I gotta log in. Can't move this to the other. Oh, there we are. Okay, so then go to the class, which is for me, it's right here. And I did not put an announcement up here, did I? Well, I'll do that later today. So click on con. Oh, I'm going to switch over to my view as a student, which I don't know how close it is to what yours looks like, but I guess yours looks something like this. And so click on content, content. And what should come up is either you see course overview, which is a copy of the syllabus, or or whatever you see, you can click on syllabus. That's the same thing. This and this are the same. But anyway, so this is the syllabus, and this is the textbook. It's an online textbook. And why don't I click on that right now so you can see what that looks like? It looks like this. Oh, it's nice I put that picture there. Uh, so you can click open the textbook, and you should, if you don't have an account, create an account using your hawaii.edu email address. And then it will, huh? What did I do wrong? That was close. So the textbook is going to look something like this. This is a teacher's version of the textbook. Did I make no, I didn't make a teaching assistant version of this one, but so yours is going to look kind of like this. If you click on reporting, this is where you can see your progress, okay? There are three types of activities in this textbook. There are participation activities, which are really easy. You just click through them, they tell you the answer. And then there are challenge activities where they don't tell you the answer, but if you get it wrong, they tell you what you did wrong, and then they give you another chance. And it'll just keep on giving you a chance until you do get the right answer. And then there are these labs, and these are where you actually have to get some working code. And I have these set so for these ones where you can get them wrong, the participation activities, if you get them wrong, you can just look at the answer and then put in the right answer, and then you get the points. Challenges, you have to get the right answer, but you can try as many times as you want. I have it where you can submit your solution as many times as you want until you get all the points. So I'll go over more of these. In fact, I'll do some examples of these in a moment, but let's go back to the syllabus. And so the book costs $89, and You get it for the rest of the semester, plus maybe a couple weeks after that. And you can download the book. You can download printed copies of the book. And so it's the textbook is open. Shoots, I gotta record this. Sorry, I gotta wait, am I recording this thing? Where am I recording it now? Shoot. I think I'm recording it. Uh, okay, I guess I'll have to, I think I'm recording on this computer locally here. Anyway, um, so, and all of the assessments are in the textbook. So you have to get the textbook. On the off chance I happen to, you you don't finish in the end and you get an incomplete, you can extend you can you can extend your subscription till the end of the incomplete period, and you won't have to pay any more for that. I'll just confirm that with me. Um, okay, in this class, the prerequisites are only ICS 101, and that's just recommended. So you should know the stuff in ICS 101. Mainly, you should know how to use a word processor, which of course everybody does, and you should know, like, understand what formulas are in Excel. To be able to write a formula all in one line, to do some calculations, and that's pretty easy also, and everybody kind of knows how to do that now, um, unless you're a senior and you don't, and in which case it's not that difficult. And in that case, you probably should take ICS 101. One thing that I mentioned is that you don't there's no programming. Programming is not a prerequisite for this course, and so we're gonna have a crash course in programming here at the end, because to be able to do stuff, you do some interesting things with databases, you should know a little bit of programming. So, of the different types of activities that I talked about, getting through all the participation activities is 25% of your grade. Everybody should get all the points because you just got to click through them. Challenge activities are 30% of your grade, and all the labs, um, that's 45% of your grade, and I guess, yeah, there's 24 labs, and I'm going to do a lot of them in class. Also, this is the same textbook that or a version of this textbook is the same textbook I use for the ICS 321 database class at Manoa that I have been teaching for a while. And there's video playlists of that course that go back 10 or 12 semesters, and so a lot of the labs and challenge activities you can find solutions to, or near solutions to, if you go back and look at those, and I'll point some of those out as we go along. So this goes till 3 o'clock. So let's go through some of these uh, examples here. We start out introducing database basics, and this first chapter actually covers a little bit of everything that we're going to cover throughout the whole semester, except for the programming part at the end. And so we begin by talking about different types of databases. There are some are just numbers, but some are, a bunch of other ways of formatting data. And this section of this chapter introduces you to that. And so, for example, here is a participation activity. To click through it, you can go double speed if you want to. You just click on that, and you talk about, data.gov provides this type of data, like weather data, or at least it used to. There's Kaggle.com allows users to find and publish data sets, and there's lots of data sets, and this this site is good to go to if you're going to do some machine learning type stuff. They got tons and tons of data. And then also there's NASA.gov. Data.nasa.gov provides data sets on aerospace and other stuff, and so So anyway, so I clicked through and I got a check mark there. And so I got all the points for this particular activity. I'm not sure how much it is, but if I go back, if when you go back to this page, you should be able to see, see your progress. And at the very end, when you click on reporting, it should be like 100%, 100%, and all the way through down, especially the participations. You should just get 100% on all the participations. Try as hard as you can on the challenges. If you're stuck on anything, you can just email me and ask me for a hint, and I'll tell you a hint. So you just need to, basically ask. And if like two people ask about the same one, then I'll probably put it in a video. Um, if there is a video which says how to do it someplace in my repertoire of all the videos, I will identify that for you and tell you where in the video to find it and so on. So I'm all for helping you out as much as you can to get these things. So let's see. So here we talk about database systems. You can click through these. Oh, let's go back here. These are to see some of these other types of participation activities. Okay, here this is simple. Like, okay, so drag and drop provides more than 250,000 government data sets. So that's probably going to be like this, correct? And then collects reports data all forms of cancer. Well, I would guess this one. And this one, by Google. Now what happens if you answer the wrong one? Like what if happens if I put this here, which just says, oh, incorrect. Oh, no, no, incorrect. And then, okay, there, I got the points. And then for this one, it'd be this one, and this one would be this one. And now I got all these points. So you don't have to, you can go through this when you're pretty tired, late at night. You come home and you don't really feel like trudging through any challenge activities or doing any labs, but you can certainly just click through this and pay attention a little bit, and you kind of get the idea. Talk about a database system, and inside there's a database, and then there's these tables here, which are accounts, and you read through this, and then you're done. Here, there's these are just multiple choice questions, and again, if you where would a bank customer's account data be directly stored? Um, I don't know. This one? Yeah. Now, if I get the wrong answer, big deal. You just click till you get the right answer. So, if you really want to, not get anything out of this, you can just go click, click, click until you get all the ones correct. But you might as well pay attention a little bit because it's a really easy way to learn. And I found in my classes and in other classes, I don't have to lecture very much. And students will go through this and read through this, and they do enough of it and they just kind of absorb it. And um, programming is it's a topic that's lends itself, learning programming lends itself to this type of teaching. So which of the following manages the bank database? Well, I don't know. I don't know. Is it this one? Oh, yes. Okay, anyway, so you click through those, get all the points. Here's another animation. Here's another multiple choice. Let's go. Let's see this. Let's see if when we start to see some. Oh, here's transactions. Transactions are just like multiple database accesses to accomplish something. Here's some more. You learn the different parts of a database system, and this query processor is the most important part. Probably the most important thing that you learn out of this class is SQL, structured query language. Here's SQL is the language for pretty much all of these databases except for maybe Mongo. But for these four, it's some version of SQL. Some of them, some SQLs have more features in them than other SQLs. So we're learning about these four, and specifically we're going to be doing some stuff using MySQL, which is probably the least it has the least features. It's the most free. So if you learn so anything you learn in MySQL will work on any of these other ones, except for Microsoft can be a little bit more strict than MySQL, and we'll talk a little bit about those later on when we get to joining tables and the fields that are supposed to correspond with each other when you're joining tables. Anyway, okay, so that's this, and so let's go and see. Let's see what these challenge activities are. Okay, here we. This is a brief overview of the four different kinds of SQL statements. There's really only four. There's for accessing the table, for putting stuff into the table, searching the table, and updating the table. So there's an insert statement, there's an update statement, and a delete statement. The update and the delete statement can actually change data that's in there already or delete data that's in there already. The insert statement is only to add new data, add a new record into the table. And a select statement is the ways that you display out the data that's in the table. A table is just like an Excel spreadsheet. It's got rows and columns. A row is a record. A column is an attribute or a feature or a field. And selecting, you specify what columns you're interested in. You're usually not interested in all the columns, just some of the columns. And what rows you're interested in, you usually restrict your selection to just certain rows that fit certain criteria, and so on. So most of this class is learning these four kinds of statements and all the different variations of that. So here's examples of writing queries. It's called a query, writing a query, structured query language. And an insert statement looks like this. The word insert and the word into, and this is the name of the table. Here, let's start this up and see. Okay, so we have a table called account. It's got 3 columns or 3 fields. We don't see any records in there yet. And then here we say it's had 2 rows, 2 records. It's got Raul's row and Mai's row. And then here we have insert statement is going to add a new row. See, insert into this. This is the ID, this is the name, and this is the balance that you're inserting. In SQL, order matters. The order of the data matters. And here is a select statement, which we're going to select just the name from the account table, all the records where the balance is greater than 3,000. So you look over here, and that's going to be Raul's record, and it's going to be Ethan's record, but not Mai's record. So this is the output. It's only the name, it's only this field, and it's only those 2 rows. So that's in select. And update means you could change, like here you change Raul's balance from 33 to 45, let's say. Update the table, set this field equal to this value, where the ID, that's this one, is equal to that. So that's an update statement. Next one is a delete statement. And there you only need the ID. Delete from the table account where the ID is equal to 572. And then I got all the points. So that's that. Go through these. Creating tables. You have to be able to create a table. So this is the create table statement. And so this is what a create table statement could look like for a table. And the field types are much more strict than they are in Excel. They're more strict than they are in regular programming languages, because in SQL, you actually have to say like the length of a string, the maximum length of a string. In fact, you have to say if a string is a fixed length of 60 or a variable length of up to 60. This happens to be, here you're saying that name is a varchar, which means variable character, which means the name can be up to 60 characters. But if this were just char, not varchar, but char, it'd be characters, it'd be exactly 60 characters. Well, what happens when you put someone in there whose name is not 60 whole characters? It fills the rest with blanks, but it's going to take up 60 characters. And then there's a date field, and date fields, consist of the year, the month, and the day of the month. And the order of those has to do with whether you're you can select whether it's the European way or the US way. And but also they are such that you can sort by the date, and it sorts correctly. And this is a number that's got a decimal point. And so it's a decimal number, and 7 means it's 7 digits, and 2 means the decimal point is between the 0, there's 2 digits to the right of the decimal point. So it's 5 digits. The salary would be a number that's 7 digits, and the decimal point is squeezed in between the first and the second, or squeezed in where 2 digits are to the right of the decimal point and 5 digits are to the left of the decimal point. So that's how create statement works. And oh, looky here, we have a challenge. So let's do a challenge activity. Do it all together and get those points. Okay, so I'm gonna start it up. First thing, insert into country. And this is fun because here, we're gonna go well into insert statements in the future, but here you're already being asked how to write an insert statement, which just kind of goes to show you how easy this is. Okay, so here we go. Insert into the table called country the values Samoa. Remember, order counts Samoa, Apia, 1100, 200,000. So that's name, capital, area, and population. So what is the new row's population? Is it Samoa? No. Is it this? No, it's this. 200,000. And check. Ah, yes, we got it right. Got a green check mark, and the check mark's up there. So now I'll go to the next one. And this time I'm gonna do a wrong answer so you can see what that looks like. So we're gonna select just the name from a table called country. There it is. We're only talking about names here, but all the ones where the area is less than 91,000. Well, that would be Korea and Honduras and not Mongolia. That's bigger than 91,000. Sierra Leone and not Norway. So it'd be this one, and that's 3 of them. So the resulting table has how many country names? Well, I'm going to put 2 just to do the wrong answer so you can see what it's like. Bang. The incorrect answer is highlighted. Oh, you expected 3. Okay, so yeah, okay. So this explains why. Should have been 3. Now you click next again. We're still on 2. Click next again, and it gives you a different question. So now select name where the area is less. So now we're doing area instead of population. Less than 2,500. So that would be the Netherlands. That's 1, 2, 3. It's 3 again, isn't it? Yes, 3. So I do 3 and check, and there we go. So we go to the next one. Oh, here, see, this is a little bit different. Delete from the country where the name is Fiji. Select the row deleted. Select the row deleted by the following query, and that would be this one is deleted. So is that correct? Yes, it is. Go to the next one. And oh, look, this is even fancier. In the above table, select the row and column changed by the following query. We're going to update the table called country, and we're going to set the population to to 29,510,000. So that would be where the name of the country is Mozambique. So we're talking about Mozambique, and we're talking about the population of Mozambique. So 10 people were added to Mozambique. Is that correct? Yes. And so now this check mark is there, and so I got all the points. So if I were to go back here and if this were mine, this is not mine because this is showing everybody. But if it's mine, this would show 100 right there because I got everything there. All right. I don't see any lab activities here, so I'm not gonna. So there's none to do. But this is an SQ. This is a sandbox where you can practice. So you can probably do this. You should probably do this tutorial, maybe. But here's a sandbox where it just has some data to start out with, and you can try if you run this right now. This this thing shows it first. If there is a student data there, it deletes it, and then it creates a new table called student, and this is these are the field types. And then this primary key, you'll learn what that is. It's a column which the only purpose is to uniquely identify that row. So usually the way it'll work is you create a new table and you'll set aside one column, which is going to increment. Each time you put in a new record, it'll increment by one. And so that way it'll be guaranteed to be unique all the time. And that way you can use that single field to uniquely identify a row if you want to update it or delete it. So that's the primary key. And so here this inserts 3 records into it. And then here this displays all of the fields, an asterisk there where you would put the name of the fields. If you put an asterisk, that means all of them. And then you want to select all the fields from student from the table, and you aren't putting any restriction on the end here. And so then that means all of them. So when you run it, that's why you see all of them. Now from here, you can do some stuff. You can fool around. You can say where classification equals freshman, like that, and we should only get Alicia. If we were to say, I want just the name, for example, I guess, name, we would get just Alicia. So anyway, that's that. And then this second one here is simply, later on, we're going to be using this fictitious database called, oh, it's not here. Is it here? Oh, anyway, never mind. I get to it. I'll get to it. Okay, so I guess this one doesn't have anything. So anyway, okay, so let's kind of go through some more of this. Gee, we might not get to 3 o'clock today because I can't. Let's just go over the rest of some more of these chapters here so you can kind of see what's going on. Okay, so the first chapter here is just on the create statement. Okay, so we start out by talking about this relational model, and that's just sort of a here. Okay, this is the evolution of databases. That's interesting. Okay, so before about the late. Yeah, I first learned about relational databases in 1972, I think, 73 maybe, and they just started coming around because computers were just finally becoming fast enough where they could have something like a general, like they could define like all data can be can be stored in the form of a table, and we'll call that a relation. It's a relation between, fields and so on, and and then along with relational databases came these nice select statements and update statements and the way to address them, and then that's when SQL came along. And then the rest of these are um, sort of as in the 90s when we started figuring out that that we didn't need to worry so much about using up all the storage. But back in the 90s, we were really worried about this proliferation of data, and we weren't going to have enough storage to store all the data, and it was going to be expensive, and we would have all these things that we would want to do to make sure that we don't use up all of our disk space, compacting it, and um, and I don't know if you've heard of Johnny Carson. Okay, Johnny Carson was the first Tonight Show host. And the reason we don't see any old Johnny Carson videos is because somebody at NBC, back after Johnny retired, somebody at NBC thought the tapes were taking up too much space, in the NBC storeroom, so they threw them all away, and so now we don't have any Johnny Carson tapes. Well, that's how stupid we were. But then in the year 2000, when the price of memory came down so much, and the speeds of the internet, were getting faster and faster. We finally came to the conclusion that we didn't need to worry about storing about how much space we're taking anymore. So now then we begin to store everything. So we store everything, and then we come down to here where there's so much data now, and we need databases like Mongo that'll much more. We can store semi-structured data and unstructured data. But this course is going to be about relational databases. We're always going to need relational databases. So we have tables and columns and rows and the data types, which is the kinds of fields, the field types. And there is different names for these in different types of environments. Databases are called a table. In mathematics, it's called a relation, and files, fields, records, and data types, and databases. A record is called a row, and so these are kind of interchangeable. These names. So sometimes you'll hear me say attribute. Sometimes you'll hear me say column. Sometimes you'll hear me say field. You'll probably never hear me say tuple, but record and row you certainly will. All right, so here, relational operations, selecting. Okay. Okay, anyway, it's some definition, projection. Okay. So let's go to, look, here's another challenge over in chapter 2. Okay, that's why. So here's another challenge activity. Let's do this one. Different terms are used for similar concepts in databases, mathematics, and file systems. Select the correct database term corresponding to the following terms. An attribute is like a field column. A relation is like a table. And a field is like a column. A record is like a row. I think that's right. Yeah. What's next? All rows in a particular column must have known values. Oh, we're supposed to say whether it's a relational rule or a business rule. I don't know. Relational rules are part of the relational model and govern data in every relational database. Oh, okay. You have to have a unique primary key, you have to have unique column names, and you can't have duplicate rows. And business rules are things like every table must have a valid entry in the department code field, numbers. Okay, so let's see what relational rules are implemented using constraints. Business rules are discovered during database design, like relation rules, often implemented as constraints. Okay, well, I don't really know the answer, so I'm just going to guess. All columns must have known rules. I'm going to say that's a must have known values. Huh. Is that a doesn't say. That's actually not, well, okay. I'm going to put, well, I'm just going to guess. All tables must have a primary key with no repeated values. That is a relation rule. When a row is deleted, all related rows should be deleted. I guess that maybe as a biz. Well, okay. I think I got two of them wrong. Okay. This one's the one I got wrong. No missing values is not necessary for all relational databases, but may be specific to a particular database or application. So it's a business rule. I see. Okay. So, um, so relational databases are able to store what are called null values, and that is as opposed to like a blank value. Like for example, let's say you have a telephone number field. Say you have a telephone number field for your employees. A blank could mean the person does not have a telephone number. Like for example, let's say it's a landline. Let's say you have a field that's got the landline for your employees, and a lot of employees don't have landlines anymore, so it can be blank, and that would indicate no landline. But if it's null, it might indicate we don't know if there's a landline or not. We still don't have the answer to that. So we'll leave it null until we know whether there is a landline or it's blank. In other words, there's no landline. So that's what they mean by business rule. So anyway, so you can do that and fix it. I only got one check mark. Let's see what structured query language. Okay, so um, we're going to learn a lot of SQL, uh, and we're going to learn all these statements. We're going to learn all these kinds of statements. We're even going to learn about transactions. Um, but uh, but and it's not so important that you understand that these are part of the data definition language, and these are part of the data query language, and these are part of the data manipulation language, and so on. It's not so important that you know all these terms. I don't know all these terms. It's just important that you know how to use all these terms. Uh, Transactions are where you can do. Okay, so there's a rule. Okay, with relational databases with SQL, there's uh, there's a bunch of um, integrity rules that are defined for a database when it's declared. Like for example, you might have like every employee has an employee ID, or every employee has you know every employee has an employee number, or every employee has a unique employee number, or some rule like that. And what that means is that the database the database will never be in a state where an employee does not have an employee number, and it'll never be in a state where two employees have the same employee number. Okay, now that doesn't mean that temporarily it might be that an employee doesn't have an employee number. Let's say you're inserting a new employee into a database, and that employee is going to be inserted in many different places, and there's a unique ID, a unique employee ID that's going to be used to identify that employee. when you're inserting a new employee, there may be a rule that there has to be a record in this table. In the regular employee table, there's got to be another record in some other table that's for the Social Security, let's say, and there's got to be for another table for something else. And uh, there and there's a rule that there has to be a record for that employee in every table. Well, there could be temporarily, it could be temporarily that while it's being entered, that a record is not uh, that it's not complete. So there's a table that doesn't have a record for an employee in it yet. Um, so uh, so uh, so a transaction would be you start a transaction and then you insert the employee into those three tables, and then you're done with the transaction. And then so while the transaction is being completed, that's not that's that's a temporary state of the database. Um, what happens is, let's say you are inserting that employee, you insert the first record, the first table, it's okay. You insert the second table, you insert a record into the second table, it's okay. And then you try to insert a record into the third table and something happens. Let's say it doesn't work. Let's say even there's a failure or the power went out or something. Okay, so what happens is you would have an incomplete transaction. Well, the database has got to be smart enough to be able to roll it back to to where the state is consistent. So the state is defined where there's a record for each employee in each of those tables. So the database has to be smart enough to roll it back to the last point where every employee has a record in every table. And so that's what when you see commit here, that's what that is. You start a transaction and then you start doing all the stuff in the transaction, and every single part of that has got to be successful. And if everything is successful, if a record was inserted in every single table successfully, then it can do this commit, and that means okay, it's committed. Now it's in a new state where it's in a new stable state. If this commit is never reached, then it will stay. Let's say that the whole thing stops, or power failure, or a disk goes bad and it can't store the data, then it'll roll back to just before it started the transaction. So anyway, um, that's what transactions are for, and we'll get to those in one of the chapters. All right, and then there's this data control language where you can control access to tables and so on, and that's an administration function. All right, so you should learn these languages. This is more important for programming languages, understanding these distinctions, uh, um, literals and keywords and so on. We'll get more into that later, but so that's all I'll say about that right now. Uh, so here's some more terminology, clauses and comments and keywords and identifiers. Keywords are special words in the language, like select is a special word, from is identifying a table, where is going to identify what's called a restriction clause or an expression here to restrict the number of restrict records that will be displayed or selected. So that's just terminology. This terminology is actually important when you're talking about programming languages in general, and I think that's probably why they bring it in here, because it's familiar to most people. This just talks about more syntax. It's called syntax, and it's just how you express the stuff, what the curly braces mean, what the square braces mean, and so on. It means it's optional usually. Square brackets enclose an optional language element. Curly braces enclose alternatives, and separated by vertical bars. We'll see more how that works. Let's see. Let me get to an actual lab here. Okay, so here's a lab. Create a movie table with the following columns. Okay, so it's a create statement. Okay, so how does this work? Well, there's two files here. There's initialize. If you click here, you can see there's two of them. This is an SQL. This is okay, they're both SQL files with SQL statements in them. This initialize just simply if there's a little SQL engine underneath here, and if you run this thing twice, you're going to want to make sure, because you're going to create a table here called movie, and if you run it twice, if you try to run it twice and you've already created the table, then if there's already a table in there, and you try to create it again, you're going to get an error because there already is one there. So this initialize thing, what this does is first run. This is the main program. First run this program. This is like a subroutine or a subprogram. First run this one, and what that is this, and this will drop the table called movie should it exist. Okay, so let's just do this. Be something like create. Can't remember. Let's go back here to the create statement. Create. Let's see, what is this here? Let's create table. So it looks just like this. And so let's copy one. Let's take this here. Can I copy this? No. Where's one I can copy? Alter. Right. Is there anything over here? No. All right, I'm just going to copy this, I guess. I'll just copy this. Copy this. Go back to here, and I'm going to say create. Say this. I'm going to paste this right here. I'm going to say create table movie. And I don't need this. And the first column is going to be ID. And it's going to be an integer, positive integer with a maximum of 65,000. Okay, so how are you supposed to know this? I can't believe you. Okay, well, it's going to be is a unsigned int. Unsigned int. Int signed int, I think. And column 2 is going to be title, and it's going to be a varchar of 50. Next is going to be rating, fixed length string of 4 characters. Fixed length, okay. Char 4. And release date is just going to be a date. And budget is going to be a decimal value representing a cost of up to 6 digits. 6 digits with 2 digits to the right of the decimal point. Confirm that the movie has been created by using a show table statement. Okay, I don't have to say that there's a primary key? I guess not. So I don't know if that's right, but I'm gonna say show table movie. I think that'll work. So show tables. Oh, okay. Show tables. I'll just do that instead. Okay, run. Okay, so here are my tables. Error, you have an error. Check the manual. Unsigned int. Okay, so unsigned int is not a type. Um, okay, so int is, oh no, int is not 65. Int goes up to, okay, I refuse to, let me just, initial model. Uh, Structured query language. No. Okay. All right. Let me just do this. Unsigned. Unsigned. Data types. Chapter 5. Data types. Integer. Integer. Uh, I want 2 bytes. Unsigned. Where do I see? How do I say unsigned? All right, so it's small int. Was that what it was? Small int? I think that's right. Int. So unsigned. It doesn't say where you say unsigned though. It's either at the beginning, it's either before or so it's small int. Let me do small int. Small int unsigned. Okay, I'm gonna say small int. Small int and maybe unsigned is afterwards. Unsigned, I bet it is. Okay, let's see if that works. Run. Okay, so I did not get an error. It just says that. This works. Show table. Well, anyway, okay, so that's my work there, and I'm gonna submit for grading. Submit for grading. Oh, 9 out of 10. I didn't get all the points. What's the problem? Budget it's not decimal 8. What? 1, 2, 3. Oh, what? Oh, okay. 1, 2, 3, 4, 5, $6, and then 2 more for cents is 8. So that's 8 places. So 6 for dollars and 2 for digits, that's 8. Or 2 for cents. Okay, so this should be 8. 8. 8 come to. Now let me submit for grading, so I can submit as many times as I want. The reason I like to have it, So you can submit, see, I got 10 out of 10. So it'll say 10 right there, is because I want to encourage incremental development where you just change a little bit, try it, see what you get, change a little bit, try it, see what you get. This is computer science. We're learning programming. You aren't going to ruin anything if you have an error in your program. Yeah. I started out in electrical engineering, and if you have an error in your circuit, you could blow up the chip. But in programming, you can't blow up the program by putting in something wrong. So um, incremental development is the best because you start out with something, you test it to see if what you put there works. If it works, then you go on to the next thing. And each time you just add a little bit. And if something doesn't work, you know it's just what you added. You know it's not, something you added 3, 4 steps ago because you confirmed each time that you added something that it worked. So I got all the points there. Let's do this next one. It's 256. So we will have finished all of the labs in chapter 2. All right, so we're going to do an alter statement. I'm not familiar with alter statements, so let's just see what happens here. First of all, it's got this column. Let's see what this looks like. Initialize looks like this. Okay, here's a nice create statement. Oh, look, I should have just gone here and seen what this was. But okay, so the initialize, first it drops the table movie and then it creates a table movie. And then what we're supposed to do is we're supposed to alter it to add this one. And we're supposed to remove that one and we're supposed to change that one. Okay, so using the alter statement. This would be here, Pico. Okay, so in 2.4, we want to where are some alters? Some alters, okay. Now, if we were to have done these, we would probably know them pretty well, but I'm going to I'm going to do this. Chapter 2, number this one, and I'm going to put this one. Can I do that here? Okay, this one here, and on this side, I'm going to put this. So these are what the alter things look like, and so here I'm going to say alter table movie add column name producer and it's going to be a varchar 50 semicolon. Can I just do 3 of them? I think I can just do 3 of them. Alter table movie um change uh current what am I doing? Oh, change release year. Current column name, and I guess I'm gonna still keep it release year. And I'm gonna change it to small int, I guess. And in between there, I'm gonna alter table movie drop genre. Okay. Okay. Let's see what this confirm by doing show columns movie. Oh, that's nice. Show columns from movie. There we go. Let's see what happens now. Let's run this. Run. Running. Running. Okay. Column 7. Did I spell something wrong or did I? All right, I'm gonna change. I'm gonna try getting rid of that and see what happens. And if not, if this doesn't work, okay, so I'm gonna do this. I'm going to instead, I'm gonna drop release here. And then I'm gonna add release. Alter table movie add release here. Small int. And I meant to do drop release here, I think, right? Release here. There, okay, let's see if that does it. Oh, current column name, alter table, change current column name to okay. Wow. Okay, well I could look at the solution, but I'm gonna ask Google. SQL. How do I change the type of a field in a table? Alter column. Oh, really? I'm gonna try that. Alter column. Where is this? Alter column. Hmm. Some systems like MySQL, Oracle. Okay, so I'm gonna say alter table. Excuse me. Alter table name. Modify. Excuse me. Modify. These capitals. Ugh. Modify column. Release year, small int. Okay, let's see what that does. All right, I'm spelling something wrong. Release. Oh, oh. See? No one said it. Change the years column to release year. All right. I'm supposed to change both that and that. See? Change the year column's name. Well, we've learned some stuff, I guess, along the way, but what I had originally was fine. I should say change 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 release year, change year to release year small int. Okay. Okay, that's change year to release year small int. Okay, see what that does. Ah, look at that. Field, blah, 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 blah. Okay, very good. And let me submit. All right, got all 10 points. Okay, so that should show you that. All right, so if you want, you can go on and take a look at some of these other things. And if you're interested, this is where we start getting into, we're going to start learning a little HTML, and here we're going to learn PHP. We're going to learn PHP. So you're going to be almost as good as if you had ITS128, but in ITS128, we're learning Python instead of PHP, but both are very, very valuable. All right, so that should get us started, and I will post this video up, and this will start the playlist, and I'll be making more videos as we go along. I'll make a video for at least every chapter, and if you have any questions, be sure to email me. All right? Any questions? Okay, thanks for watching.